So as we have seen that while discussing AES and DES, that DES encrypts or decrypts the data which is of 64 bits, and AES encrypts or decrypts the data which is either 128 bit, 192 bit, or 256 bit. So both of these algorithms, they operate on fixed size data, right? But when we talk about real life applications, then not always we have the fixed size data to operate on, right? So we have variable size data which needs to be encrypted and decrypted. So what do we do in that case if the data is not of 64 bit or 124 bit, or if you specifically want to use DES or AES? So for that thing, we have a number, we have various modes of operation which we can use to implement any of the algorithm, any of the ciphering technique to encrypt the data. Okay, so that is the thing it is telling you, that we have this fixed size blocks in AES and DES, right? So we need a way to we need a way so that we can encrypt or decrypt arbitrary amount of data. So we have five operations which can be used so that we do not get bound to the size of data. Okay, right? So if we want to use AES, then we should not be bound to use a block of 128 bit. Okay, so that will be up to our choice कि हमें कितने बिट का डेटा उस कितने बिट का ब्लॉक हमें कंसीडर करना है. Right, so these mode of operations, they have block and stream modes, both the modes we will be using. So in total, we have five modes of operation which we can use for encrypting and decrypting the data. And these modes are the first one is electronic code book, then cipher block chaining, then cipher feedback, and output feedback, and the last one is counter mode. Fine. So we will be discussing these modes of operation in detail one by one, and we'll understand that what are their disadvantages, what are their limitations. Fine. So the very first one is electronic codebook mode. In this mode of operation, we break the message into independent blocks which are then encrypted. Okay, so we will be dividing our data into a number of blocks, and each block will be encrypted separately, right? So each block is a value which is substituted like a code book. Hence, it is called electronic code book. So what we do, we get a cipher text for the different blocks of the plain text. Okay, and we keep track of those cipher text, on the basis of the plain text blocks which we have got. We keep all those cipher text, just like we manage the code book. So that is why we use this name electronic code book mode for this mode of operation. And each block is encoded independently of the other blocks, right? And the method which we use for encrypting the block is this one. So here this example is considering the DES algorithm. Here we can use AES as well. Fine. So we get the ciphertext block corresponding to this plain text block. So that is why their subscript is similar. So this is CI, which is the ciphertext block corresponding to PI plain text block after applying this key K1. Fine. And key will be similar to each and every block. So this method, this mode of operation, we use for secure transmission of single values. So that is a limitation as well for ECB. That is we can handle small amount of data with it. We cannot rely on it for sending large quantity of the data. That we'll discuss in the later slide as well. So how do we perform the operation while using ECB? So this is how the ciphertext blocks are generated. So this is the block 1, which we have represented as P1, and we are using the same key for each and every block, right? Now out of this P1 we are getting this ciphertext block C1. For P2 we are getting C2, right? So this is the encryption process for each and every block. Now the size of block is predefined, right? And if in the last block the size of bits, it becomes short of the number of bits, then we go for padding, राइट? तो जितनी भी बिट्स उसमें कम पड़ेंगी उतनी ही बिट्स हम लोग उसमें पैडिंग कर देंगे उतनी बिट्स की. So just like this encryption process, we have the decryption, okay, wherein we use this decrypting thing, decrypt process. It will take the ciphertext block as the input, and with the help of key it will generate the plain text block. Fine. And that is how we will be generating each and every plain text block, okay, and at last we get the whole message. So that is the working of electronic codebook mode, right? Now these are the advantages and limitations of ECB. So message repetition may show in the ciphertext. Now what happens, since we are using this same key, okay, so if the block is same, if P1 and P2 they are equivalent, then the ciphertext will be similar, okay. So in that case the attacker could identify that for block which the attacker has intercepted, उसके similar जितने भी blocks होंगे उनको बार बार उसको intercept करने की ज़रूरत नहीं पड़ेगी. So the attacker will be having the results for the same blocks in one go, right? So that is the disadvantage. So its main use is sending a few blocks of data. It is not appropriate for large quantity of data, which I have already told you. Fine. Next we have is cipher block chaining. So this is the second mode of operation. In this operation as well, the message is broken into blocks and they are linked together in encryption operation. Fine. And we are linking them together. That is why we call it block chaining, right? So that is why we use this word chaining over here. So we will be making use of the previous cipher, okay, to find out or to process the current plain text. So how do we do this? We'll discuss it in the next slide. So each previous cipher block is chained with the current plain text block, and hence we call it the cipher block chaining, because these things are chained together, right? And now we are talking about this previous cipher block. Now if we are at any intermediate plain text block, and that is fine, we can find out the previous cipher block, right? But if we are at the first plain text block, then how do we find out the previous cipher block? For that we have this initialization vector with us, which we use for the first block of the plain text, right? So I'll be telling you that how do we use this this first vector for processing the first block of the plain text, right? So here the the cipher block is generated using this expression, this one. So how does it work? It simply perform the XOR operation between the plain text on which we are working on and the previous cipher block, right? The XOR operation is performed and then we combine it with the key, okay, then we apply the key over it. Fine. And this C minus 1, that is the cipher block which we use for the very first plain text is C minus 1. So we call it as we represent it as IV, which is the initialization vector. So this initialization vector, it is it is agreed upon by both the sender and the receiver. It can be any random bits into this vector. Fine. So this mode of operation we use for bulk data encryption and for the authentication purpose. Fine. So how does it work? We'll see now. Now we have divided our data into, we have divided the plain text into a number of blocks, right? This is P1, this is P2 up to Pn we have. Now for the first plain text block, we have this initialization vector. Fine. So they will be XORed first of all. That is, this expression is telling you Pi and the previous cipher block. They are XORed first of all. Now, since we are talking about the first plain text block, that is why we are considering here initialization vector. So they are XORed and then we encrypt it. Okay, after the result which we get after this XOR operation, we encrypt that result using the key. Fine, and as a result we get the first ciphertext block. Now in the plain text block 2, now since now we are talking about an intermediate plain text block, so we will be using the previous cipher block for it, okay, for the XOR operation. We will not be using here the initialization vector. Fine. So here we will be using this C1, okay, from here, and we'll be XORing it with the plain text block, and on the result we'll be applying the cipher along with the key, and we get the second block of the ciphertext, right? So this is how we encrypt all of the blocks of the plain text. Fine. Now that is the encryption part. Now while decrypting the message at the receiving end, what happens? We consider this C1, okay, and its corresponding P1 has to be generated. Now in this we will be decrypting this C1 using K, okay, and the result will be XORed with the initialization vector, okay, so which we have used over here, right? So as a result we'll be getting the P1, which is the first block of the plain text. Now this ciphertext again will be fed, or will be chained with the second round to get the second block of the plain text, right? So here again we'll be having this C2, okay, and we'll be decrypting it using key K, and the result will be XORed with the previous cipher block, right? So that process you have to understand, that in this we were chaining the output, okay, and while decrypting we are chaining the input which we are giving into the decrypt algorithm. Fine. So this is the cipher block chaining mode, in which the previous cipher blocks are chained together. Fine. Now these are the advantages and limitations of CBC. Ciphertext block depends on all blocks before it, because we are connecting all of the cipher blocks. So here this C2 will depend on C1, C3 will depend on C2 and C1, and so on. So they are depending on each other. Now any change to a block affects all the following ciphertext blocks. So that is again because of this dependency. कि अगर कोई भी change होता है, so that will be affecting the following cipher blocks. For this we will be requiring an initialization vector which we represent as IV. It must be known to the sender and the receiver. Okay, so it must be sent secretly, because if it is known, then the further process will be very easy for the attacker. So for sending the initialization vector from sender to receiver, we can use the electronic codebook mode, okay, which is very suitable for sending the short messages. Fine. So we can have it can either be a fixed value or must be sent encrypted in ECB mode before rest of the message. So that is we can be having we can have a fixed value for it or random bits for it for initialization purpose, okay, for putting up the bits into the initialization vector. Now next mode is cipher feedback mode. Now you have to understand this mode very clearly, because this is somewhat confusing to understand it. Now in this ciphering mode we make use of the feedback, okay. This is we treat the message as a stream of bits in it. Now since if we see at its working, we will be talking about the blocks of the data, but the message is treated as the stream of the bits. Now add it to the output of the block cipher. So that is why we call it as feedback, क्योंकि एक जो भी फेज होगा उसका जो आउटपुट आएगा हमारे पास उसको हम feedback करेंगे नेक्स्ट में, ठीक है. So how do we use it, how do we implement it, that we'll see in the next slide. The result is feedback for the next stage, and that is why we call it the cipher feedback mode, right. Standard allows any number of bit. We can choose out of it that how many bits are to be fed back, and depending on the number of bits you choose, we have these standards for it, CFB 1, 8, 64, 128, etc. So in this we use these rules for encrypting the message or decrypting the message. So what we do is, here as well you can see we are making use of the previous cipher, right. So this cipher is fed back into the next stage, and we are also using the initialization vector, okay, because we need to deal with the first block of the plain text using this initialization vector, right. So how does it encrypt the plain text block? We have to see it from here. So first of all, what we do is, the previous cipher block will be encrypted using K1 key, fine, and the result will be XORed with the plain text block, right. So this might sound confusing right now. Once I'll show you the diagram or kaise process hota hai, then you will be understanding it. Now this previous cipher block we are talking about here. So in case of the first plain text block, as I already told you, we will be considering this initialization vector, fine. Now come to its diagram. So in this CFB we make use of shift registers, right. So here very first thing we have is this initialization vector, okay, and here if you do not consider it as a shift register as of now, I'll tell you what is the purpose of taking this shift register over here. So this is the initialization vector. Here it is represented as 64-bit, right. Now since we are discussing the generalized version of these modes of operation, so we can consider it n bit. This initialization vector is of n bit, fine. Now this initialization vector, which we call as the previous cipher block, it will be encrypted using this key, okay, and after encrypting it, what we will get the value which is 64-bit long, or we can say which is 10-bit long, okay, if we talk about the generalized version, right. Now after this, what happens, now we are done with this thing, this part of the expression up to this, okay. So we have encrypted the previous cipher block, and in the case of first plain text block, we have encrypted the initialization vector now, okay, which is n bit long. Now we have to perform this XOR operation with the plain text. Now the plain text size is S bits over here. Okay, we can see it. This is S bit. Okay. Now this S is, it is always, in some books you can find it is always less than or equal to N. In some books you can find this is always less than N. Okay, so that, that is fine. If we consider it equal to as well, then there is one step which we have to, ignore over here. So if we consider it, equal to or less than equal to, we will be able to understand it. So you can consider it, anyway, right? So here we are having this 64-bit, right? And this plain text is of S bit, and we have just seen that this S is, less than or equal to N. Now if it is equal to N, that is fine. Now if this S is less than N, then what we have to do, we have to perform this XOR operation. Fine. So performing this XOR operation will need the equal number of bits in both the operands. Fine. Now this P1 is S bit long, and the message which we are inputting from here is N bit long. So what we will do is N, or we can say B, because B is written over here. I don't know why I said N. So this is B, right? So what we do is we will discard, we will only consider the S bits out of the B bits. Okay, and B minus S bits we will be discarding. Now say for example, I'll tell you with the example. Say for this initialization vector is of 64 bits. Fine. We have encrypted it with the key. As a result, we have got the 64-bit data over here. Let me use the eraser. So over here, after the encrypting process, we have got the 64 bits over here, right? And say for example, this plain text block which we have, the plain text which we have broken into a number of blocks, it is of 50 bits. Each block is of 50 bits, right? So now we have to XOR the 64 bit with the 50 bits of the plain text, which is not possible, right? So what we do is we will discard these 14 bits out of the message which we have got over here. Okay, so after discarding these 14 bits, we are left with the 50 bits now. Now we can perform this XOR operation. Okay, so that is why this thing is written over here. We select the S bits out of it, and we will discard the P minus S bits out of it. Then we'll perform the XOR operation. So that is the left part of this expression. We perform the XOR operation between the plain text block and the result which we are getting after applying the encryption operation over the previous cipher block, right? So we are XORing both of these values, and as a result we get our first cipher block, right, which will be S bit long, right? क्योंकि यहाँ पे दोनों इनपुट S bit long थे, इसकी भी जो लेंथ है वो क्या होगी? This will be 50 bits, right? So now we are having the output for the first step, which is C1, which is the first cipher block corresponding to P1. Now here you can see that we are not applying this encrypt operation over the plain text. We are applying the this encrypt operation over the initialization vector, right? In the further steps as well, we will not be applying this encrypt operation over the plain text block, right? This plain text block we will be adding, or we will be XORing at the last step in the whole process, right? So now how do we use this feedback feature in this mode of operation? So now we have this first block of cipher with us, which is C1. Now this C1, we will be feeding it into this shift register, right? At the first step, we have this initialization vector. from the second step onward, we'll be having this shift register with us. Now, what we do in this shift, the size of this shift register will be equivalent to this initialization vector, which is b bit or n bit, right? So what we do is we will be shifting the contents of this shift register, which are equivalent to this initialization vector. We will be shifting them to the left by s bits. Okay, तो इनको लेफ्ट शिफ्ट करने के बाद now we have space for entering s bits into this register. Okay, because we have shifted the b bits by left by s bits, right? So we can feed these s bits of the cipher block 1 into this register now, right? So this register will be having some bits which were initially into it, and all of the s bits which we have fed back from the C1. Okay, so as a result, we'll be having, in total, we'll be having 64 bits in it. Okay, or in generalized way, we will be having b bits into it. So again, the process will be repeated. We will be encrypting those bits using the key K, and as a result, we'll be getting the 64-bit data, and we will be selecting S bits out of it, and we'll be discarding the B minus S bit out of it, and the result will be XORed with the P2 now. Okay, because we are in the second step. So जो second block होगा plain text का उसको हम XOR कर देंगे result के साथ. So as a result, we'll be getting the second block of the ciphertext. Okay, and this second block will be fed into the third step. जो third वाला register होगा, third step में हमारे पास जो shift register होगा, we will be feeding it this C2 block into that register. So उसमें भी हम कैसे feed करेंगे? We'll be shifting the contents. जो अभी यहाँ पे जो contents हैं, we'll be shifting those contents by s bits. Okay, we'll be shifting those contents left by s bits, and we'll be adding these s bits into that register, and then we'll be encrypting it with the key K, and then again we'll be selecting s bits and we'll be XORing it with the third block of the plain text, which is P3. This process goes on until you reach to the last plain text block, which is the PM. Okay, and at last we get the CM over here, which is the last cipher block. Right. This is how this encryption process goes on. Now, one more important thing in cipher feedback is we make use of the encryption process at both the encrypting end as well as the decrypting end. So this mode of operation is designed like that. Okay, we will be using the encrypt operation at both the ends. Now, because we are not applying this encrypt operation directly on the plain text, okay, we are applying this encrypt operation on the shift register. Okay, so at the decrypting end as well, we'll be having this initialization vector. So the process will be same, but this C1 which we have generated over here, it will be XORed with this output, okay, which we have got after the encryption operation, and from which we have considered the S bits and discarded the other bit, because C1 is, this is also of S bit long. So we will be having this C1 for for the first step, okay, and we will be XORing it with this output which we have got from the previous operation we have performed. As a result, we'll be getting the first block of the plain text. Now this C1 again will be used as a feedback to the next stage of the decryption process, and the process will be same. इसको फिर से हम we will be shifting it left by the s bits, और कुछ बिट्स इसके अंदर बच जाएंगी और बाकी बिट्स की जगह हम ये जो cipher text है इसकी s bits को we will be inserting it. Okay, फिर से encryption process होगा. We'll be selecting s bits out of it. Now at the second stage, we'll make use of this C2, which we have generated from here, right? So this C2 will be, XORed with this output which we have got from here, and as a result, we'll be getting the second block of the plain text, right? And this process goes on until we make use of the last cipher block and we generate the last block of the plain text, right? So this is the working of the cipher feedback mode. This, I know this is somewhat confusing, but once you will listen to it carefully, that will be easy for you. And these are the advantages and limitations of CFB. It is appropriate when data arrives in bits or bytes. This is the most common stream mode. That you have to note that the block cipher is used in encryption mode at both the ends. That I already told you that we are using the encrypt operation at both the ends, at the encrypting side and the decrypting side as well. So that is the design of this particular mode of operation. The problem with this is error propagate for several blocks if it appears. अगर कोई error आ जाता है because we are feeding back the output in the next stage, so it will propagate for several blocks. Okay, so to overcome this problem, this limitation, we have the next ciphering, next mode of operation, which is the output feedback mode, right? So in this mode of operation, we treat the message as a stream of bits, just as we treated it in cipher feedback, which is CFB. Okay, and output of the cipher is added to the message. So we will be, considering the output now, okay, not the cipher block. And which output we are talking about, that I'll show you कि पूरे process में से कौन सा वाला output हम लोग we will be feeding it back. Then this output is then fed back, and that is why we call it as output feedback. And now this feedback is independent of the message, because before XORing the plain text with the output, we feed it to the next stage. So now since we are not making use of the plain text over here, plain text block is, before using the plain text block, we are finding out the output. So that is why we can compute it in advance. Right? And the cipher text or a cipher text block is computed using this expression. So we XOR the output and the plain text, and the output will be, this output will be the previous block, okay, the value of the previous block. In the first case, in the first stage, this will be the initialization vector again, and we will be applying the key, and as a result we'll be getting the output. So this might sound confusing right now. I'll be showing you the diagram, the things will be clear. Okay, its use is, this is a stream encryption on noisy channels. So I'll show you the diagram so the things will be clear. Now this is how this output feedback work. So if you remember the cipher feedback which we discussed earlier, in that we were we were performing the operation in same way, but the result which we were getting over here was being fed back into it. But here in the output feedback mode, what we do is we feed back this output to the next stage, not the cipher block. So that is the thing which is written over here. Okay, output of the cipher is added to the message, okay, and then output is then fed back. So what we do is we will be considering this output. Now this process, if you remember, it is same. For the first step, this is initialization vector which is predefined, okay, which is of b bits. Okay, here we considered it as 64 bits. we encrypted it using this key K, and after this we selected S bits and we discarded the B minus S bit. वो मैंने आपको एग्जाम्पल भी बताया था using 64 and 50 bits if you remember, right? So these S bits will be given to the next stage as the feedback. Okay, and then again what we will do, this shift register will be shifting the contents of this register, which are this initialization vector, ये as it is हम इसमें use करेंगे, and then it will shift its contents left by S bits, और जो भी positions बचेंगी हम वहाँ पे we will be copying these S bits over here in this register. Okay, and this process goes on, right? So the difference between the cipher feedback which we discussed in the previous class and this output feedback is only this one, that in cipher feedback we were feeding back the cipher block which we got over here, and in this output feedback we are feeding back the output which we are getting over here. Okay, so I'll show you the diagram of cipher feedback as well, so that it will be clear to you कि क्या difference है. So here this value is going to the next stage, right? And in CFB you can see that the cipher block which we are getting over here, after performing the XOR operation we are feeding it back to the next stage, right? And rest of the process is same in this. In just like CFB, in OFP as well we are using this encrypt operation at both the ends, at the encryption and at the decryption. Fine. So in this in the decryption step as well, what we will do, we will be feeding back the output, and XOR operation के लिए will be using the cipher block, right? तो ये वाली जो value है that will be going into the next stage, or we will be using it for the next block of the plain text, right? So this is how this output feedback work. Okay, so this difference you have to keep in your mind, and you do not have to get confused in both of these things. So the main thing is in output feedback you use output, and in cipher feedback you use the value of the cipher, right, for for the next stage. Fine. Now these are the advantages and limitations of OFB. Now in this, bit errors do not propagate, which was the problem with CFB. Why? Because in that we were using this cipher block for the next stage, right? So यहाँ पे अगर कोई bit error आ जाता है, so that will be going into, that will propagate to a number of levels. But in OFB, because we are feeding the output only to the next stage, so this problem of error propagation is not there. Now this OFB is a variation of Farnham cipher, and it has this limitation that we can never use the combination of key and the initialization vector which we have used for any plain text. अगर एक plain text के लिए हमने उसको ट्रांसफर करने के लिए एक कॉम्बिनेशन यूज कर लिया है of key and the initialization vector, we cannot use that combination for another plain text. Why? Because you can see it from here, अगर key और initialization vector का combination same होगा, so the same s bits you will be generating, right? और वही वाली s bits हम लोग next जो level है उसमें pass करेंगे, feedback करेंगे. Okay, in CFB we were not passing this value, so वहाँ पे जो changes आ रहे थे किस वजह से, because of the plain text, क्योंकि plain text is different every time, so in that case it is fine. But in output feedback mode it is not fine to use the key and the initialization vector pair again and again, the same pair, right? It is more vulnerable than CFB. So that is, these are the limitations and advantages of OFP. Now the last mode of operation is counter mode, which we represent as CTR, right? So this mode of operation is similar to OFP, but instead of you know this particular mode of operation, it uses the counter, a value, a counter it uses rather than the feedback value which we were using in cipher feedback and the output feedback, right? It also must have a different key and counter value for every plain text block. Okay, so the reason is same, क्योंकि हम plain text को बाद में add कर रहे हैं, उसका XOR हम बाद में कर रहे हैं, so that is why we need to use a fresh combo of the counter and the key value for each and every plain text which is to be encrypted. And the process which we use for encrypting the message is this one. So what we do is we will be generating the output using the key and the input. Here the input is that counter, fine. This I is the counter, fine. And the CI, which is the cipher block, which we are generating by XORing the plain text and the output. So here as well, as I told you, with the plain text block will be introduced in the last stage. Okay, so this CTR is somewhat similar to output feedback, but instead of using the feedback, we are making use of the counter. Now it is used for high-speed network encryptions. Now let us see its diagram. So here you can see that instead of using that initialization vector at the first place, this is similar to initialization vector actually, but we call it as counter. Why? Because for each and every step we have to increment it, right? So that is why we are naming it as counter. We are using a counter over here. So this counter we have, along with this key, we perform the encrypt operation. Then the result of this encrypt operation, which we have represented as O in the previous slide, this one, okay, and the plain text block, they will be XORed, the output and the plain text block. So as a result, we get the cipher text block, the first cipher text block. For the next plain text block, we will be incrementing this counter by 1. Again, the same process will be followed. So this incremented counter will be encrypted over here, and then we get the second block for the cipher text by XORing the output of this unit and the plain text, the second block of plain text. And this process goes on until we reach the last plain text block, right? So the total number of counters we'll be having is this n minus 1, right? Okay, so here the total number of counters we'll be having will be n, right? Okay, so at the decrypting end, again, because we are introducing this plain text block at the last stage, so the decryption will be, using the encrypt operation as well, just like cipher feedback and the output feedback. Okay, and the counter which we have used over here will be used at this step. The counter which we have used over here will be used at this step. So the counters will be same level wise. Okay, and instead of XORing the plain text with the output, here at the decrypting end we will be XORing the output and the cipher text block, the first cipher text block which we have got over here. As a result, we'll be getting the first block of the plain text, and just like this we can get the each and every block of the plain text back after the decryption process, right? So that is the counter mode. Now, these are the advantages and limitations of counter mode. It can do the parallel encryptions in hardware and software. It can pre-process in advance of the need. Why? Because we are using यहाँ तक जितना process है वो advance में हम लोग करके रख सकते हैं, and later this block of plain text can be XORed. Random access to encrypted data block, it is its security is proved. It is as good as the other modes, but must ensure that you never use the used key and counter value pair. Okay, so that is the thing which we have to consider. Now we have discussed all the modes of operations, right? The very first one was electronic code book, in which each block of plain text bit was encoded independently using the same key. Okay, then we discussed cipher block chaining, in which the input which we gave to the encryption was XORed uh, uh, with the next block of the plain text and the preceding block of the cipher text. So in the cipher block chaining, the output of one stage was chained with the input of the next stage, right? In cipher feedback, what we did, the input was processed s bits at a time, and the preceding cipher text, the previous cipher text, was used as the input to the encryption algorithm. Okay, and that was that was used with the shift register, and the shift register we used for shifting the bits of the previous uh, initialization vector or the previous shift register. Depending on its position, it was shifted s bits, and then the new bits were inserted into it. In output feedback, instead of using the cipher as a feedback, we used the output as the feedback. And in counter, instead of using the feedback, we we used the counter. Okay, a counter for a separate counter for each and every stage, and each counter was incremented by 1 from the previous counter. Okay, so that is all about the mode of the operations in block cipher.